Welcome to the Programming Electronics Academy podcast. Join us every other week as we explore how everyday people are creating extraordinary things in the world. Find us online at programmingelectronics.com.
Hello, I hope you're doing fantastic. Thanks so much for taking the time to join me today. This week's guest, really interesting talk. It's with Will Osman, and he's got a really pretty funny YouTube channel where he makes a bunch of interesting things and shares them. A lot of them have to do with Arduino and electronics, and we're going to be talking about some of those projects and kind of how we got into Arduino and electronics and stuff. So without further ado, let's go ahead and jump right into the show. Well, hey, Will, thanks for taking the time to talk. I really appreciate it.
Yeah, no problem.
So you've published a bunch of videos. You got a really interesting website, and you're doing stuff with Arduino and electronics. But before we kind of jump into some of the project specifics, I guess I'm just curious about your journey and how you ended up started getting interested in electronics and Arduino and that type of thing.
It was probably 2012. Well, actually, the first Arduino I ever bought was in 2009, maybe. It was the, however you say, the Dessa Buenoville. The very first one.
I know.
I still don't know how to say it.
Neither do I.
And I was trying to do some little like a not motion capture, but a little time lapse rig where it would spin a product around and you could take pictures of it from every angle. And I kind of did that one little terrible project and gave up. And then a couple of years later, I was working at a company with a lot of really smart people, and I wanted to build for my personal project a motion control system, like for filmmaking, where you can move the camera and repeat the movement over and over, and you can do time lapses with cool movement. I'm sure you've seen some of these videos online where they'll do time lapses out in the desert, and the movement really adds something, but it's hard to do. And so, working with a bunch of smart people, I was asking them for help, and I was sorry, I just need more context. I was working in the shop doing a lot of basically manual labor, and I'd hang out with the engineers every once in a while. And so I'd ask them for help, and they kind of got me pointed in the right direction. And during this time, I was going to school for mechanical engineering, but had really no experience with electronics or Arduino or programming or stuff like that. So I basically just started working on this motion control system, and I'd always have questions from my friends at work, and they'd be able to answer me because I've got much more experience with microprocessors and that sort of thing. And I worked on that. I'm still working on that motion control system, and I think I'm on like the second version. I worked on it heavily like 2 years ago, and I kind of stopped after I started working on some other projects. But I basically spent a bunch of time working on one project, and that's where like the core of my sort of Arduino experience comes from.
I guess I'm curious a little more about like how the project worked, like what the scope of, so like motors to move this thing, something to interact with the camera, or
it basically is a little track, like a camera slider, camera dolly, something kind of like that. And it's got a motor that can move it along the dolly, a motor that can twist the camera left and right, and then I put motors to focus the camera. And so the controller has to sort of do all these things in real time. And if you want acceleration and stuff, then that's where things get way more complicated. Because accelerations, depending on how you're doing them, if you're doing like true acceleration, like a single acceleration, that involves like square roots and stuff. If you're solving, depending on how you're solving it, like if you're looking into the future and saying I need to take a step with my stepper motor at this time, and you have acceleration in there, the time between steps slowly decreases, and it's based on a square root. So you end up with, some little bit more complicated math that has to happen really quickly, that you kind of start pushing the limit of the Arduino. But yeah, the idea is you move a motor and it moves the camera, and then you can, got a little user interface with some buttons and a screen and stuff like that. And you can kind of program, I want you to start here and end here and take, 20 minutes and take 500 pictures, and kind of like, I guess, I'm not sure if that's a good.
No, that is good. I think I definitely have a good picture of it. It seems like a good project to kind of pull in, like obviously a lot of challenges there and a lot of stuff to have to learn. Were you a programmer before you started with Arduino?
No, that was the biggest struggle, I think, is programming is, it's difficult. It's not difficult, but it's difficult because you sort of have to wrap your head around a completely different way of looking at things and solving problems. And so that was definitely the biggest challenge. Is I know I want to do A, B, and C, but I have no idea how to do it, in what order, how do I organize things. Yeah, so that was the biggest challenge, is learning basically how to program. And that's all part of this one project that, I spent a bunch of time on. I've done other projects too, obviously, but this was one that I've definitely sunk the most hours into, where I've learned most of the, concepts. And
Yeah, I feel like projects are great ways to learn, because it's like learning that's contextualized around some type of goal.
right. Yeah.
It's just, it can, especially if it's a project that you're genuinely interested in. It's one thing just to like, follow somebody else's project or build somebody else's. But if you're like generally interested in the build, then man, it can be a huge motivator for like getting crap stuck in your head.
Yeah, I feel like that's the problem with school nowadays, is they like, a lot of people don't realize that what they teach you in school is just a tool to let you do something you want to do. Like, just because you don't like math doesn't mean it can't help you. It's just a tool. You don't have to enjoy it. You just have to, know how to use it to get where you want to go in the end. And I think having that project, having something that you're excited about, sort of gives you a reason to learn how to use these tools, where you say, I don't really care about the tool. I just want the end product, and I want to, use the tool to get there. So yeah, definitely having that project, the motivation, is so important to, helping you like stay inspired and learn and chug through problems when you get stuck.
So you're putting some videos on YouTube, and I think that's actually how we came across what you were up to, was YouTube. Would you mind talking about a couple of those projects? Some of them are kind of crazy.
Yeah, sure.
The one, I don't know if you'd be interested in talking about the Cosmos one.
Yeah, so I had the opportunity to work on the set of BattleBots season 2 for ABC, and some of my coworkers had a robot, and that robot was Chomp. I'm not sure if you're familiar with the show at all.
I'm not. But...
And so they were one of the first robots in the history of the show to do some like really serious automation, and have this horrifying 250-pound combat robot with a giant pneumatic hammer auto fire and auto target and track their opponents. And they had some success with it. They had some other issues, but the way they were communicating with their robot was via Cosmos. And Cosmos, that's how I learned about it. And it's like, one of the challenges with Arduino is getting information out. And obviously you've got like serial print to send stuff over USB so you can see individual data values. But if you really want to see like parts of your machine or system that, I don't know, it's like the hardest part about electronics is and programming is you can't necessarily see what's going on. You have to sort of output, you have to make some sort of interface so you can see things going on internally. And that can open the doors to letting you see things that you wouldn't have otherwise seen, that are either problems or ways to improve. So typically serial print will only get you, so far. And I think they've introduced some sort of graph, but Cosmos allows you to basically send a bunch of data, or allows you to send data out and then visually sort of interpret it without putting a lot of effort into setting up that kind of user interface. And so it really gives you a lot of, like, imagine if you could send values directly to Excel from an Arduino, and you could have it like graph in real time, and you could put buttons and stuff like that. It's like everything you wanted about a user interface, except you don't have to spend a bunch of time, like finding a processing sketch someone wrote and running that on your computer and then hacking that and, trying to, configure that into a user interface. Cosmos basically does that for you. It's a little bit of a nightmare to configure, Cosmos, like to get it all set up. But once you do get it set up and you kind of figure out how it works, it makes it so easy to just dump data out and graph data in real time and like you can send commands, you can visualize data. Like it's so powerful. And so, it's free, and it will really give you some insight into, the project you're currently working on if you need to get information out.
So is it like a library that's working on top of, or how does it interface?
So it just sends or it receives like raw binary data, which I guess is how everything works. But it'll send like you have to tell it exactly what it's receiving. So you say, I'm going to send you a packet, and you, instead of serial print, you serial write out of the Arduino, and so it's sending the raw bytes, raw bits, and because typically, maybe too much detail, but typically when you serial print, it's sending the ASCII.
Right. Yeah.
It's not sending the actual numbers. And so you have to serial write, which will send the raw number, the raw data. And then you tell Cosmos in a text file, you say, there's going to be the first byte is this, the second byte is that, and then I'm going to have a 32-bit, variable here. And so it basically pulls that data and then, cuts it up in that order and interprets it that way. So there's no library, there's no nothing. You're just sending raw data and then telling Cosmos what it's going to receive. And then with Cosmos, you can get really fancy and you can have different packet structures, and you could make things, I think you could make things dynamic if you wanted to. I kind of did that. But yeah, you basically just, the general structure, there's some code, but you make a struct in your Arduino code, which is just it's almost a single variable that's a list of variables. Does that make sense?
Yeah, no, it does. I'm following it. I think we've got some pretty technically privy people in the audience, but I appreciate you taking the time to kind of explain it, because there's also I'm sure there's some people listening who might not be at all familiar with it, so I appreciate that.
Okay, awesome. Yeah, so you can make a struct, and you can fill that with all the values you want to send over, and they're all different. They can be floats, they can be, Booleans, they can be anything. And then you just simply, say name an instance of your struct like Cosmos dot data one, and then you could say, dot data one, dot data two, dot data three, just all the different values that are stored in that sort of instance of the struct. And you just send that to Cosmos. And as long as you've told Cosmos the kind of basically what that structure looks like, it'll know how to pull all those values in and chop that byte stream up into, dump everything in the correct place. And then it does with that data what you want it to do with the data.
That is sweet. So it's working obviously on like a PC? Is it working on a Mac?
Yeah, I think it works. It's so the software itself is like aerospace stuff. Apparently this is like stuff they use for really serious aerospace engineering. And I think it works on everything.
That's cool.
I think. I could be wrong, but I'm pretty sure it does.
Cool. And so, and then you configure it to output to whatever you want. Is it have easy setup to let's say you want to send it to Excel? Is that a common?
You can save the data. Actually, I think it automatically saves the data for you. So the instant you start logging, if you turn it's called a telemetry grapher. If you start the telemetry grapher and data's coming in, it'll just immediately start saving it, and then you can export it as a CSV. You can. I haven't played too much with it, but you would just save your data and then bring it into Excel.
That's really cool. I didn't really know too much about this this tool. That's cool. I can't wait to explore it more. So what were you using it for?
So I was using it for I was helping a friend out. He is on a formula team in college, and that's where you build the race cars, the gas race cars. And they were, it's kind of funny, but you want to see what's going on, and I guess much like programming, you can't really see what's going on. Some things on a race car you can't really see what's going on either, because it's out away from you or it's hidden deep within. And so if you want to look at a bunch of data points from your car, like the battery voltage, how fast you're going, you can basically look at everything and display it on the screen at the same time, and you can maybe draw some conclusions that you wouldn't have otherwise drawn before. And so we were trying to build an inexpensive telemetry system for them that you could completely customize and would send data wirelessly to a computer, quarter mile away. And that's basically that was the first thing I did with Cosmos.
That's cool. Has it worked out all right?
Yeah, so they ended up, the telemetry system was kind of the last thing they needed. They were having, problems just getting the car working on minus that. So, it's something that down the road they will be able to take advantage of. But at the time it was kind of all right, well,
speed zero, it's not moving yet,
Yeah, exactly. No, it would have helped with battery voltage, because they were having problems with their battery and they didn't realize it was dying, because they abused the battery pretty badly, way over discharging it and stuff. So if the telemetry system had been set up at that time, they would have seen that the battery was basically needing to be replaced.
That's hilarious.
Yeah.
So you one of the other projects you have on YouTube was trying to get your dog to to steer your dog, and
Okay.
it was like it was hilarious. That was a hilarious video. I thought the production of it was great, by the way.
Thank you.
How you kind of walked people through the phases, but it is a pretty silly video. Could you kind of talk through the project?
Yeah, so I had the idea, and I thought it was an original idea, and until someone pointed out to me that Simone Yates had done something kind of similar, so I was kind of bummed. But we started with basically, what if you were to dangle the hot dog in front of the dog's face, and then if you could steer it. I mean, I guess that's pretty obvious. That's what the project is, but it was just kind of like, would that even work? You know, like the donkey carrot thing. I
Right.
can't even think of how I thought of this project.
I don't know either. I have no idea how you would have come up with it.
And so I started working on just the actual CAD model, and took some pictures off Google of English bulldogs, which is what my family's dog is, and threw those into SolidWorks and used them as reference, and then kind of built the little backpack. And then I love doing this, but I made a thrust bearing with marbles. I'm not sure if you remember from the video, but basically put a bunch of marbles underneath the platform that the hot dog hangs off of, and that's what the whole thing swivels on. And so instead of buying a bearing, I made it out of marbles. And
That's awesome.
yeah, and then used a DC gear motor that I pulled out of. Did you see the pumpkin robot? I
I did
reused
not see the
all
pumpkin
these
robot.
motors and parts. So I built a pumpkin robot that I fought my coworker's, real 250-pound BattleBot, and she smashed it. But like all the components survived, and so I've been reusing them for all my other projects. And one of them is a DC geared motor on the back, and so that gear motor spins the platform, and then there is a SparkFun IMU sitting on the stick, far away from the motor because it was freaking out. The magnetometer was freaking out being too close to the motor.
Okay.
So the IMU provides angle data. It says, I'm at this angle, and then the controller knows where it wants to be, and then it drives the motor to get the IMU angle to be what it wants it to be, in a little PID control loop.
And IMU, is it like inertial?
Inertial measurement unit.
Okay, gotcha.
So they'll, if you have an accelerometer, you get 3 pieces of data. If you have a gyro, you get another 3 pieces of data. But when you throw the magnetometer in there, you get like absolute reference to the Earth.
Mm-hmm.
And so you get a much more accurate, and I'm not sure how it works, but they basically pre-mix all the data for you on this board, and so they give you just angle output.
Was it hard to use?
No, they make it pretty easy. The only challenge, and I've been reusing this IMU for a ton of different projects, and so I have some code that I use. And the one thing I didn't really understand is you can tell it to output binary data instead of ASCII data, so that you can basically, process it faster and it's easier to code. But the problem is you have to take this data out. You have to take 32 bits and you have to dump it into a float. And so you have to do some wonky C that one of my friends a while ago helped me with. You have to use some pointers and address. You have to do like a couple flip-flops to dump the data from a 32-bit variable into a float variable.
Gotcha.
You can't just say it's really weird. It's like I don't maybe there was a better way to do it, but that's how we ended up getting it to work. You can't just make a 32-bit variable equal to a float,
Right.
because it'll convert it for you. As opposed to we wanted to literally dump the raw binary data. So that was the only problem. That was like the trickiest part, is getting a raw 32-bit stream into the, into a float variable, like, location, like wherever that memory was.
That's interesting. Do they have a library that works for it that just kind of like?
There might be. It's like, it was only like one line, but it's just like a weird, it's like a bunch of like brackets and quotes and amperstamps for all the pointing, and like it's
I know,
like
level of complexity with brackets and quotes, like increasing number of those, increasing complexity. It's kind of funny.
Yeah, it's one of those things that you look at like when you see a complicated math problem and there's a bunch of letters in it, and you're just like, what the heck is this? Like, there's not a cleaner way to have done this. Like, it just.
So how did it? Did it work out? Did the dog follow the hot dog?
Kind of. Yeah, he's kind of lazy though. you can't even walk this dog. I mean, you can try, but you'll make it like a quarter of a mile and then he'll stop and you have to carry him back. So we probably were using the wrong dog to begin with, but I was a little worried about putting this on, a dog I didn't know as well and having them like freak out. Not, necessarily worried about the electronics because that's, whatever. Who cares if it breaks? It's just, I don't want the dog to like freak out and go running and, and you can't do stuff like that on the internet because people will not be happy.
Well, it looked like a very friendly video. I mean, I think the dog seemed pretty happy.
Yeah, he was. People still made comments though, where I was like, they're like, oh, you're teasing him. And like the dog ate an entire package of hot dogs. He ate like 8 hot dogs. Like, how is that animal abuse? Like, he couldn't be happier. Maybe mildly annoyed, but
That's awesome.
He did okay. There were a couple points where he would try to jump up to get it, and he would walk forward sometimes and then stop, and I would say it like 40% worked.
Well, that's I mean, a success indicator.
Yeah, I think we actually tried it on another dog too, not in the video, and kind of similar reaction where the dog was just more confused about what was going on, that he wasn't really concentrating on the hot dog. And, we ended up getting the dog to walk like 10 feet. This was a boxer, way more energetic. And he made it like 10 feet and then kind of stopped and said, I have no idea what's going on. So
what are you working on right now? You got like big plans for the future?
Yeah, I got a crazy project I'm working on right now that I've been on the struggle bus. It's a mechanical TV. It actually, like a viewer suggested this. Someone emailed me, and it's a TV that it was like the first TV ever made, and it works by having a giant spinning disc with a single spiral of holes on it. And that masks the light coming in from the lens and going out to the TV. So you've got like 2 components. One is the mechanical camera and the other is the mechanical TV. Turns out the mechanical TV is the easy part. The camera is the hard part. But, if you take a lens and you hold it the focal length away from like a piece of paper, you'll see the image that the lens see get projected onto the paper. It almost looks like a projector, like an overhead projector.
Okay, right. Yeah, I can kind of visualize that phenomenon.
Yeah, so you can actually see it, and so when you take a picture in a film camera, a digital camera, it's literally projecting the image onto a piece of film or onto a digital sensor, and then the sensor samples a bunch of points across the image, and you get a digital or film image. So with the mechanical TV, they couldn't capture a bunch of data at the same time unless it was like film. And so if you wanted to send TV wirelessly, you could do it over a radio signal, but that only gives you 1 data point over time. And so what they would do is they had a giant spinning disc, and the holes on the disc would only allow light from one portion of that projected image from the lens to make it through to a single sensor behind the disc. And so it was almost like the camera was only sampling like 1 pixel at a time, and that pixel was scanning across the screen, and then another hole slightly higher up would come onto the screen after the other one left the screen, and it would scan another line across the screen. So you would scan like 24 to 32 lines across the screen, and those lines, one at a time, would vary in amplitude as it went across the screen, would be sent over a radio wave to your TV, which had a light in it and a disc that was synchronized and spinning the exact same speed at the exact same time, and that would block light that was behind it, only allowing it to go through that one tiny hole to that one spot on the screen.
Okay, I think I've followed what you've said then. All right, so you're transmitting that image 1 pixel at a time from one place to another, and you're essentially just blocking the light for each pixel. Okay, right. So are you building both ends of this? You're building the mechanical side and the TV side.
Yeah, and so I've hooked them up. So I think the one thing, I don't know how they did back in the day, was synchronizing the TV and the camera. That seems like a challenge, but they managed to do it. Because you could imagine if they weren't spinning the same speed, the image would get distorted because the pixels would be at the wrong spot at the wrong time.
Right.
Or if it was if it was out of phase, right? So if the camera disc was, twisted 90 degrees more than the other one, your image would get kind of split across the screen, like the VCRs when you pause them, how the image would kind of like distort, like it would get cut in half. So what I've done is I've put them onto the same motor, and so the discs are basically spinning at the same time, and the TV is they're both on the same side of this sort of weird little wooden frame I've cut, so you could like put your face in front of the camera and you could see it on the screen.
Okay.
Yeah, so the hard part, or at least what I've realized is the hard part, is the camera and the amount of light actually making it through the camera into the back into the sensor is like not very much. And I'm doing it kind of ghetto, not really proper optics. Like I use a flashlight reflector to help try and guide the light towards the sensor, but it's so little light that I've had to amplify the output of the phototransistor like crazy. And I was using some long wires and it was picking up, 60 hertz. Like if anyone works with any analog stuff and with like high impedance, so like not generating very much current, it allows sort of everything in your house to affect it. So if, you have a power cord or the lights or anything like that, you'll see 60 hertz. Like you'll see 60 hertz everywhere because of your AC power.
Man, that's awesome. How long have you been working at it right now?
God, I was hoping it would take like a week, and I think we're looking at like 2 weeks now. And so last night I figured out basically I was using way too long of wires to hook up to the photocell or to the phototransistor, and that was allowing that 60 hertz signal from everywhere in the house to come through. And so I made a little circuit board, used way shorter wires, and hopefully I can get something working today, and then we can finish the video we've filmed for it.
Is there anything else you want to share about stuff you're up to, or if somebody's out there like learning to program and learning to figure out how to use Arduino, any recommendations for them?
I don't know about recommendations. I mean, all I know, what I always tell people is, people watch Harry Potter and they love magic and stuff, and I'm pretty sure using an Arduino and some basic electronics is as close as you can get to being a wizard as possible. Yeah. And like you can basically do anything, and you just got to find a project that's inspiring and find resources online. And pretty much everyone's already done something, and pretty much anyone who's done that has documented it and told you how to do it yourself. So, even if it sucks at first, you can usually piecemeal something together by looking at a bunch of different people's projects, and you can literally make anything. Well, maybe not literally, but you can make a lot of stuff.
Yeah. I mean,
you can get pretty close.
Yeah, it is amazing how accessible so much stuff is, and I look on some of the different vendors like SparkFun or Adafruit or whatever, and all the cool stuff. The components that they do sell, it's just, I don't know. It's so easy to come up with ideas of stuff to do, and it's just.
And they give you like completed boards. You could, buy a bunch of things and put it together, even if you didn't necessarily really understand what was going on, just to get a start. I mean, that's how it works. You just kind of do things until it works, and they make it so much easier by having kind of pre-made things. And
and I feel like if you're just getting into it, it's okay to like mimic something else. Like it might not feel like a ton of learning, but I mean, I think mimicry is still a form of like you're kind of figuring some stuff out, right? And then you just kind of like iterate on that stuff to maybe change it up to what you're looking for. I don't know.
It gives you confidence. I think when you even just getting something working kind of on your own, even if you don't really understand what it was doing, gives you confidence. Like, wow, I can do this. I just have to figure out how this works. But it's not like a totally kind of untangible or non-tangible thing. Like you can get a project working even via mimicry or a kit or something, and then you can tinker with it and you can poke around and see what happens when you change a variable number or something like that. So I mean, I guess the answer to inspiring is just literally do anything. Just try something, do something.
Yeah.
Absolutely. And failure is always an option. Like I still struggle with things, and you look at it and I'm like, I don't know how the heck I'm ever going to make this work. And in the end, pretty much everything ends up working. You just have to spend enough time and struggle enough and don't give up on it.
Well, I hope you enjoyed that talk as much as I did. It was a pleasure talking to Will. We'll definitely make sure to link to the videos that we discussed in the show. You can find those in the show notes. And also, if you haven't, I'd love for you to rate the show. You can do that in iTunes or Google Play or wherever you might be listening to the show. We really appreciate that. And if you haven't yet, you can subscribe. I hope you have a wonderful week this week. Thanks for taking the time to listen. And I'll see you in a little bit. Bye.
This show is produced by Programming Electronics Academy, an online technology education company. We exist to help you create the technology you want in your life. If you are interested in learning more about Arduino, we welcome you to sign up for our free Arduino crash course. a 12-part video series with accompanying written lessons designed to teach the basics of programming Arduino. To register for the course, simply text your email address to 440-701-5311, or you can visit programmingelectronics.com and sign up there.